So I want to briefly show an example of an attack in Castle and how Castle is able to mitigate that and to trick the attacker. So I'm going to add a bot in this case. And the bot is going to mount an attack. This is a credential stuffing attack. So very briefly, if this is new to you, unlike a brute force attack or a dictionary attack where an attacker has a list of passwords or is just really guessing a password for a single attack, in this case, we're assuming the attacker actually has a list of usernames and passwords. And maybe this is something that they stole, maybe this is something that they bought online from a previous data breach, but they already have a set of credentials. So for them, the purpose of this attack is not to guess a password, it's actually to try out sets of credentials and see which of that set is a hit. And from there, they can sell that refined list for a much higher value than what they bought it for. They may not ever even log into the account. So what they're looking for is not necessarily what they can do inside the account. They're just trying to see, do the credentials work at all? Because if they work at all, that's a good sign that they can sell those credentials for a higher value. So let's go ahead and mount the attack. You'll also notice that they're rotating through IP addresses in order to avoid being pegged at one IP, right? So again, even the attacker is taking advantage of mixed identities in order to be able to mount this attack. So let's say that they've mounted this attack, and in the midst of it, they happen to have the correct username and password of one of our users. So instead of giving them any positive signal that they have successfully logged in, instead of saying, oh yeah, here's your account, or this is suspicious, here's a one-time password, there is no positive signal at all. As far as the attacker is concerned, this was a complete failure, right? And this is extremely important because it means that their entire set of credentials is burnt. It looks like it's useless. And this may not be even that surprising for an attacker. Maybe they got scammed, maybe what they stole just didn't have any matches. So they're more likely to just leave this site alone because they think that nothing is going to work on it. Meanwhile, in the background, we've given the user plenty of information that they need to make the right decision. We've said, hey user, we noticed that there was this unusual attack using a headless Chrome browser from Japan. You may want to reset your password because otherwise your account would have been compromised. And even at a user level, again, we're interested not just in the identity of the user, we're also interested in the behavior on the account, all of the devices that are accessing the account. And here we see that there's this very high risk event emanating from Japan. So based on these signals, we identify risk. And then based on how all of this ties into one single account, we understand the overall health and safety of that account. So in this case, if our user resets their password, then they're able to log back in. And the risk associated with that account is also somewhat lowered. Now, this is just on the level of a user, but consider at a higher level. Those attacks may affect multiple accounts, and it's extremely important to be able to see that activity at a higher level. It's not enough to just look at one particular identity. And from having that high-level overview, we're also able to identify malicious signatures for specific devices, right? We're considering more than just the principle of a human user. So in this case, we've seen device-based risk and how we build a profile based on attributes of the device. And really just tying this back to the idea of principles and identity, this is because we're expanding our understanding of identity to also include other principles or other components. We're not just treating it as another factor. So over time, we've seen that logins might be optimally protected, but what happens when an attacker does get into the account? When they do get into the account, we still want to be able to anticipate certain types of risky behavior. So for example, is it an unusual time of day that they're doing something? Are they trying to withdraw an unusually large amount of money. Is their bot-like behavior even once they've gotten past the login, right? Suppose that there was a challenge where they needed to identify a kitten in an image and they were easily able to circumvent that challenge, but now a bot is moving around inside the account with those compromised credentials. What do we do then? In that case, having the ability to customize our policies and to be able to say at a fine level of detail, I want to ensure that even if someone gets in, any bot-like activity is going to be detected and blocked, right? So even if they are able to log in, say they hijack a session or are able to phish a one-time password, right? And then they try to make a withdrawal. Couldn't complete the withdrawal because we have this risk policy that identifies certain traits indicating a potential bot, right? So even after they've gotten past login, they're still stopped dead in their tracks.